Uh, it's for me to make a presentation in stand position. Yes, please excuse me. Well, I would like to express my great gratitude for having us here and warm hospitality to invite KWRA's delegates. And actually, I would like to express this is my great honor to make a keynote speech in front of all the members of Thai Hydra. Well, today, this morning, I brought the drought issues of Korea. And I would like to introduce the drought management technology of Korea in line with climate change adaptation. Well, I prepared a couple of slides. The slide was the recent research result of my colleagues with me, and I worked with the government officers who take in charge of drought management of Korea. And actually, I heard 2015 also Thailand experienced very severe drought. So I hope these issues may be interesting for all the people who attend here. And first slide I prepared here is the recent abnormal water extremes in Korea. So as you can see, and the first slide is flood perspectives that you can see every year the Korea experienced the flood, whether it is big or small, because of two reasons. First one is that the monsoon climate pattern makes the heavy rainfalls. Number two is, in average, 4 to 6 typhoons passing Korean peninsula or Japan's and east part of the China. It's the main reason why I experienced the flood every year. And as you can see, the change of annual precipitation is almost 13% during past 30 years, from 1200 to 1400. Much more, the increase of frequency and intensity of heavy rainfall, but decrease in rainy days. It means that two extremes happen every year. And second slide shows the drought perspectives of Korea. Drought actually not happen every year, but you can see by this very schematic diagram shows the very interesting truth that every 4 to 6 years, Korea experience very, very severe drought. So we experienced the severest drought in Korean meteorological history at 2014 and 2015. It was tremendous disasters. It's catastrophic for Korean people. So we can forecast the next drought going to be happen around 2020, 2021. Yeah. So this is the main topic. And so the Korean government tried to invest research fund for the climate change assessment and climate change adaptation. Actually, the first phase of this research was initiated in 2009. So that research was focused on the climate change assessment. And this is the second phase of the Research Center for Climate Change Assessment. They focused on the climate change adaptation. And there are 4 groups for entire research center. The number 1 group focusing on the flood issues. Number 2 is the drought issues. Actually, I and my colleagues associate with the group 2. And group 3 is the watershed management adaptation. And group 4 is the new water industry for changing climates. And they have their own missions to get some research results. Expected outcomes going to be summarized right here. The group 1 have to make IDF, PMP, PMF maps for considering the climate change. And group 2 have to make establishment of national emergency plans for extreme drought and some joint dam operation rules to cope with the drought issues of Korea. And group 3 have to make a technology of decision making for climate change adaptation. And group 4 have to focus on the construction national virtual water database system. So it's now working very well, and the result of that research will coming out at the end of the 2018 or 2019. So from now, I will show you the very interesting result of my research that I'm associated with group 2. So I have to make what is the drought and how severe drought we have to prepare for changing climate in the future. So first step I did is that I have to define that what is drought. As you can see in these interesting figures that drought can be defined as the temporal water imbalance, which was caused by nature, not by human beings. If temporal water imbalance was caused by human beings, we call it water shortage, not the drought. So drought and water shortage is quite different. But every scientist, every water resources management misuse and mingling that definition. So in this study, I will monitor the drought issues. So when the water imbalance is very long, it's permanent, that's the desert. If there's no rain in the desert, that's not drought. That's natural phenomena. There's no water shortage in there. So I will monitor the first quarter of the left-hand top side drought. And drought can be categorized in 3 different ways. First one is the lack of precipitation is a specific time period make meteorological drought. When it's getting longer, then it accelerates evaporation in soil moistures and make vegetation stress, make agricultural drought. Here is the Rural Irrigation Ministry, so maybe interested in this agricultural drought. But when it's getting longer and longer, that evaporate the reservoirs and there's no water in the stream flow, make hydrological drought. So drought can be categorized in the 3 different ways. And then, how severe drought we have to prepare? So we have to prepare mega drought. Mega drought can be defined as a prolonged drought lasting 2 decades more than maybe 20 years, 10 years drought. Why? Because 1 year, 2 year lasting drought, it's okay, no problem. Every country's the water resources management skill can overcome 1 or 2 years drought. There's no drought. That's no problem. So, scientifically, the mega drought is described the decade-long drought or multi-decadal drought. So that means drought is the main importance is the length of the drought, not the severity of the drought. Yes. In flooding case, we used to say that what's the return period of that flood, what's the magnitude of that flood, but drought is very, the duration is one of the most important issues of the drought. So then where is the extremes? Most of the science try to find the extremes in the future climate change because future climate change scenarios reflect the historical observed data as well as the trend of increasing trend or decreasing trend. So many scientists think that there might be extremes in the future climate change, but I don't think so. Because there's a very big uncertainties. There are many assumptions. They use the very climatic models. So I try to go back to history. So this is the current actually Korean government started their very systematic precipitation observation system from 1908. But in our history, the King Sejong of Joseon dynasty started to measure the precipitation from 1441, about 700 years ago. It's amazing. So I tried to find that the precipitation data from the palace diary. They recorded every in the morning, which millimeters. But unfortunately, from 1442 to 1776, record was burned out because of the war with Japan. So I can't find it anyway. Anyway, I can use from 1777 to 1907 precipitation data by that Chugugi. It looks like the very same size with the modern rain gauge facilities. It's amazing, the same size. So I used the three different time frames. First one is paleoclimate, very ancient data, and modern observation data, and future climate change data. I tried to find where is the extreme drought event among these three different time frames. And let me show next interesting slide that in 130 years, the Chigugi ancient recording gauge have a very unique decreasing trend. Yes, it's decreasing. But when it comes to the modern contemporary period, from 1908 to 2016, its modern observation system shows the very unique increasing trend. Because I think that's because of the climate change effect. And the future 100 years climate change scenarios, there's no trend. It's very stabilized trend right here. And as you can see, the annual precipitation of Chigugi is 1200 and modern observation is 1300, but the climate change shows a 1700 annual precipitation. Of course, it's different, depending on which GCM you use. I just used the head GM, which was modeled by England, Great Britain. And anyway, there's a big difference in the annual precipitation, but the seasonal precipitation is quite the same. Yeah, for three different time frames. And I implemented outlier analysis. Then I found some very interesting truth that ancient period, there are many dry years, 7 to 30. And when it moved to the contemporary, it's very balanced. Wet year is 8 count, dry year is 7 count. It's very balanced, but still a little bit increasing. And then when we move to the future climate change scenarios, there are only floodings and too much precipitations. So there is a big cycle of dry from the wet in Korean. I'm talking about in Korean case. So I calculated a standardized precipitation index. It's one of the very famous and meteorological drought index. Calculated index, then I can find the very extreme scenarios, not in the future, from the past data. So from 1778 to the early 1902, or about 17 straight years, the Joseon Dynasty experienced one of the severest drought in Korean history. Some historians tell us that the collapse of Joseon Dynasty is the main reason is that drought, 13 years lasting drought. Yeah, that's true. So one more interesting thing is that last year's the drought of Korea, 2014 and 2015 was ranked at 5th. So it was very, very severe drought in Korean history. And now I will show you then Korean government how to monitor the drought in Korean case. The conventional method, as I explained in the previous slide, that there's three different drought categories. First one is meteorological drought, can be monitored using the precipitation data and temperature data. And agricultural drought can be monitored by the soil moistures and crop conditions. So Ministry of Agriculture will monitor the agricultural drought, and the Korean Meteorological Agency monitor the meteorological drought and agricultural drought. Also, hydrological drought can be monitored using the stream flows and reservoir storages. So this is the simple website of drought monitoring site of Korean government. The left-hand side is the Korean Meteorological Agency's drought monitoring system. They just monitor the meteorological drought using the temperatures and precipitations. And that's the drought monitoring system of KWRA. KWRA is one of the largest water supply organization of Korea. They just try to monitor the domestic water supply drought and reservoir storage drought. So they are quite independently operate their system by their own. Also, Ministry of Agriculture have their own drought monitoring system. But there's quite a limitations for drought monitoring using the ground-based gauging stations such as precipitation and soil moistures. So I started to work on another phase using the satellite information because that we have to using the interpolation because there are very sparse weather stations, and sometimes we get to know the information of North Koreans drought phenomena or East Asian countries drought phenomena. So I used many different types of satellites. So the precipitation case, I used the Persian trim GPM satellite, and to get to know the information of vegetation and land surface temperature, I used the Terra and Aqua satellite, which was launched by NASA, United States of America. And Solomons case, I used the AMSR and ASMAP. Then I can make a drought map in different phase. This is same period drought map using different information of satellites. So we can get the meteorological drought, agricultural drought, and hydrological drought using the satellite information very effectively. Sometimes in North Korean case, sometimes in East Asian case, sometimes we can get the information, drought information of a global case. So this is the sample example. This is the left-hand side is a drought, agricultural drought damaged area of 2001. So north part of South Korea was severely damaged by the drought in 2001. If we monitor that drought damaged area by SPI, that's a meteorological drought index using the precipitation, it's quite different. There's southern part, but damage is north part. It's not accurate. But when we use the satellite information of the vegetation with composite with the land surface data, it makes very good accurate drought areas monitored by using the satellite information. So it's very effective and very powerful way to monitor the drought using the satellite information. I heard that some of the scientists in Thailand already started to use the satellite information to monitor the flood and the drought. And we can monitor the East Asian countries, Japan or China or Southeast Asian countries, and North Korean's drought can be monitored by this system. And also, drought monitor is not important because drought forecasting is very important. When does it terminate? When does it start? So this is next phase research for my work. And there are three different ways. First one is physical model, like numerical models using the Galois land surface model and VOP. And number two is the statistical method using the Bayesian networks and artificial neural networks and fuzzy theory. When you get much more longer forecast, we have to use atmospheric teleconnections, El Nino and La Nina, and climate pattern change in the region. Very large scale drought forecasting is capable using that atmospheric science concept. And this is the website of KMA's drought forecasting system. It was implemented by our research team. So we can forecast 1 year, 1 month, 2 months, 3 months drought condition can be forecasted using artificial neural networks. So now I'm working on some hybrid statistical forecasting model, combining the ensemble empirical model composition method with the artificial neural network algorithm to get to know the much longer forecast possible. And number 4 is, what about the drought preparedness of the Korean government? So there are 5 different ministries involved in drought. Number 1 is Ministry of Public Safety and Security. They have a responsibility for drought alert, drought warning, drought prepared for the human beings, for the public of the Korean peoples. And number 2 is Ministry of Land and Infrastructure. They monitor the hydrological drought with K-water and water supply. And number 3 is the Ministry of Agriculture. They monitor the hydrological drought information. Also, taking charge of water supply for the agricultural use. And number 5, Ministry of Environmental. And number 6 is Korean Meteorological Administration have tried to get the information about meteorological drought. All different drought information are gathered, transferred to the Ministry of Safety, Public Safety and Security, and analyze the current state and future state and make a drought warning based on these 4 different warning levels, like blue, attention, yellow, watch, orange warning, red emergency. The Ministry of Public Safety make a drought warning and forecasting systems. By this condition, there are very detailed conditions listed of this table. And last year, after 2014-2015 very severe drought, Korean government made this drought disaster risk management manual for 5 different ministries, very specific and a very step-by-step process for reacting and response to the drought. And now I'm working on the research that make the potential drought hazard area by drought frequency analysis. This first map shows the drought hazard map using the historically observed data. So conventionally, southern part of Korea has a very drought vulnerable area. When I use the climate change scenarios, that area is moving. As you can see, S1 period of next 30 years is moved to northern part of Seoul, and Gyeonggi is a very drought vulnerable area. So you can see S1 period, the red colored severe drought area, then S2, S3. So in next 100 years, drought area gonna be moved from the south to the northern part of South Korea. So the Korean government have to make a special plans for the northern part of Korea. Actually, the 2014 and 2015 drought was focused on northern part of Korea. The scientists' result tests have very good relationship. And now I'm doing with the government officers is that the drought management framework was finished and try to make a drought guidelines, much more specific than framework. And then finally next year I start to make a drought action plans, emergency plans for, to cope with the mega drought during maybe 10-year lasting or 5-year lasting. So now I'm reaching to the conclusions that drought, some people never understand why drought is that significant, because it's not frequently happen like a flood. But every place in the world right now is suffering by the drought. For example, the United States, California drought is lasting 6 years. So many of the scientists tell us that the mega drought will grip the U.S. in the coming decade. And is California entering the mega drought? I think it is true, yes. It's a sign of a mega drought. It's lasting more than a decade or 10 years. So the California government of water resources already started their reacting drought, this mega drought. Also Thailand, suffering from the worst drought in decade at 2015. It's amazing, yeah. And North Korea is still suffering from the worst drought in a century. And as you know, the Brazilian drought in São Paulo is lasting this year. It's a very serious situation. So also Australia suffers worst drought in 1,000 years. Every place in the world is suffering drought. So now I'm willing to tell you is that the drought is a very creeping phenomenon. It's hard to understand when does it start. It's hard to forecast when does it end. So exceptional drought, sometimes lasting more than a decade. So if we do not prepare for the drought, we have to pay for it. It's a catastrophe. So I hope you're getting through drought beyond. And thank you very much for your attention. And thank you.